Hey everyone, welcome back to another ENCOR study group session. Today we are going to be covering enterprise network design. We've been covering a lot of design principles because really what we're doing is we're going through the blueprint of the ENCOR. And so we're starting right at the beginning with 1.1 section, and we're going to continue to go through this blueprint step by step. Now, just kind of as a general, here's how this works kind of thing, just keep in mind that this video has been pre-recorded, and so I am able to answer any questions that you might have as we go through this video. So I'm here in the chat with you, so please feel free to jump into the chat, ask your questions. And by the way, if you're studying for the ENCOR and you've got questions about something other than what we're covering today, in other words, enterprise network design, then feel free to chime in with those questions, because if not me, then somebody else in the chat might be able to answer that question for you and get you going. So this is an enablement for you. This is an enablement for everyone who's going through the ENCOR right now. I want this to be as beneficial as possible to you. And the reason we're doing this in an interactive fashion is for the sake of that interactivity. And I just dropped my pen. All right. So anyways, today we are going to be talking about 3-tier and 2-tier designs. So what we have is a couple of things. We're going to be covering 2- and 3-tier designs. In other words, when we have to collapse one of our layers onto each other. But then also we have to worry about when we have to connect to the access layer. And the access layer can have a lot of different design ideas and philosophies. It can be a layer 2 design, it can be a layer 3 design. And so we're going to cover a lot of the access layer ideas here in this session as well. So without further rambling, I think we're going to go ahead. I almost flipped the pen right out of my hand again. We better get going before I throw my pen across the room. All right, so when it comes to architectural design, I'm trying to think of how exactly to say this, we have to mesh book smart with street smart. In other words, we have to find the balance between what looks good on paper in a book and, designing and architecting these things according to network theory. But then we also have to worry about what is real world, like what actually is the best scenario depending on what we are actually faced with. And so, in my background, I've said this before, but I've done hundreds of network designs over the years. My role was working with a Cisco partner, and I went into organizations and I looked at what they had and said, hey, this is what you have, and here's what we'd recommend. Maybe your network is 10 years old, or maybe things have changed, you've grown, and you need to expand your network. Whatever the situation is, we need to build a network architecture around what you need. And that's always going to be the goal. So let's start off with this concept of a 3-tier design. In the enterprise world, we like to split our networks up into places. Remember we talked last time about this idea of having a core network block. And we also talked about how a network block typically is going to have 2 switches in it, maybe more depending on what exactly is happening in there. So 2 for redundancy, and then we're going to connect our 2 blocks together. We're going to connect those 2 switches to the 2 switches in another block if we want to connect 2 blocks together. And so this core is supposed to be the hub, sort of in the middle of everything. And so we've got this network core, and we are going to connect all kinds of other network blocks to it. So for example, the data center, that's a network place that I love to hang out in. It's got all of our servers and our storage and applications and data all stored in the data center. We might have our internet block. But where we're going to focus today is this concept of a campus. So think about a campus. It could be literally a school campus. It could be an organizational campus. Cisco has campuses. They're a large enough organization that they've got multiple buildings within a single geographic area of one another, and they call that a campus. And so when you have a campus environment with multiple buildings, what you end up having is the need to connect all these buildings to one another. And so what we do is we typically will have a distribution layer in every single building, and that is the responsibility of the distribution layer is to, number 1, provide layer 3 connectivity back to the core, and then number 2, to provide access to everybody in the building that needs access. And typically what we're going to do for that is deploy an access layer. So I think I misspoke there. The distribution layer's role is not to connect the people, it's to connect the access layer to the rest of the network, and the access layer is where the users live. We'll write that down here. Incidentally, I need to make sure that and there goes my camera. All right, I need to make sure that I don't draw underneath my head here. All right, mark that off. So we have core, distribution, and access layers in this enterprise network design that we've clearly laid this out and established this. And so our users are going to connect to the access layer. Our distribution layer is going to be responsible for things like VLAN interfaces. These would be the SVIs. It's going to be responsible for maybe some access control lists. We'll put the ACLs at the distribution layer. And we covered last time how, what the role is of the distribution layer and access layer and such. And so if you missed last time, I keep saying last time because it was 2 weeks ago. If you missed that session, then be sure to go back and watch that. It's here in the same YouTube channel. So what we've built here is a 3-tier architecture. This 3-tier architecture consists of a core layer, a distribution layer, and an access layer. And each one of these, again, is a pair of switches. And so physically, I'll erase this here in a moment, but physically what we have is something that looks like this. We've got a pair of core switches connecting to a pair of distribution switches, and then who knows how many access switches, all right? I mean, I've been in campuses where we've got dozens of access layer switches. I've even seen a dozen access closets, and each closet would have, 5 to 10 switches. So we can get a lot of access switches in an environment. So we're going to have however many access switches that we have all connecting in through that distribution layer. That's physically what that looks like on the right side. Again, I'm going to go ahead and clear that off so we have space to do the rest of our conversation. But I want to make sure that we have the idea of what this physically looks like. It's not, we go out there at some point, we're looking at actual switches, and those switches are connecting to actual other switches. And we do need to translate this conceptual diagram into actual real world physical connectivity. All right, so we have this concept of 3-tier design, but this is where it starts to get a little bit away from the book world, because in a real world scenario, my entire organization might fit into this diagram as I've gotten drawn, as I have drawn out here. I might have a core switch and a pair of core switches and a distribution layer and a bunch of access switches, and that's my headquarters. And I don't actually have a campus. And so really I bring my data center and everything else into this core switch, and this is my whole network. Okay, that might be the case. But it might also be the case that I'm on an actual campus, and so now I've got other distribution switches, other distribution blocks coming in. So this might be my building 1 distribution layer, and then I've got another building nearby that's building 2. And then I've got another building that's building 3, and I might have dozens of buildings on my campus, and each one has a distribution layer. And usually hanging off of a distribution layer is going to be an access layer. So again, we think about universities, we think about companies like Cisco having a lot of different buildings within a single geographic area. Usually this is going to be connected all together via dark fiber. We call it dark fiber because I like the fiber myself. I put a transceiver or an optic on both ends of that, and I light it up. I'm not paying somebody else to light up that fiber. So that's why we call it, I didn't write it out, but that's why I call it dark fiber. Okay, so we've got this concept of the 3-tier architecture, and you can very clearly see how we have this established, where every single building gets its own 3-tier architecture. But at the same time, you'll notice that we're all sharing that core layer. I mean, that's the whole point of a core, is to connect all of the different building blocks of our network together. And so all of this is layer 3 connectivity. If one distribution block needs to communicate to the other distribution block, then the core will facilitate that. Most of our communications, of course, are going to go up to the internet or up to the data center. We're not typically doing a whole lot of peer-to-peer applications in this day and age. So all that to say, this is well and good. But now we need to realize that this very rarely fits into an organization. Very rarely fits exactly like this into a university or just wherever we're deploying it. And here's the reason for that. The reason for that is because the roles and responsibility, let me change my colors here. The roles and responsibility of the distribution layer do not include connectivity to clients. So my users are all coming in to my access layer, and that's great, except what if I need users to come into the distribution layer? What if I have a relatively small building, I'm bringing my dark fiber into the building, and you can imagine this like, maybe they converted a house into an office. And so we're bringing this dark fiber across the campus into this little house that's got maybe 15 people working inside. And so we drop a network switch in there, maybe even 2 switches for redundancy because we're trying to do our due diligence. And then I need 15 connections, and they're all within a small space. So am I going to put 2 distribution switches and then also 2 access layer switches into this little house? I mean, chances are I'm going to put 1 switch. I mean, maybe I'll put 2 switches, but for the most part, I'm just going to put a single switch in there and terminate that dark fiber and give connectivity to those who are in the house. So what did we just do there? I mean, if we're going to bring everybody into 1 switch, what's that concept? And that concept is collapsing. So collapsing means that I'm taking 2 discrete layers or 2 discrete networking blocks and I'm collapsing them or combining them together. So in my case with the house, let's say that this is the house here. Building number 3 is just a small house. I'm going to bring these 2 layers together, these 2 building blocks together. I'm going to collapse them. And so this becomes a collapsed distribution and access switch. So I'm still running layer 3 back to the core. However, I'm also, and I should also say from a distribution layer perspective, I'm also running the SVIs and I'm doing any ACL work, and I've got the first hop redundancy protocols. I didn't write that over here, but first hop redundancy protocols like HSRP and VRRP and such. And I'm doing all of those things. However, I'm also connecting users. And since I'm connecting users and doing all of the roles of an access layer block, for example, we mentioned QoS marking. That's something that belongs on access layer switches. So does VLAN tagging and such. And so I'm doing all of the roles and responsibility of both the distribution layer and the access layer. And that's this idea of a collapsed design. So this, in a way, becomes a 2-tier design, because now, even though I've got 1, 2, 3 tiers here, well, I mean, I guess I already wrote that out. This is still valid, right? We still have a 3-tier architecture going to building 1. And as of right now, we've got the same concept going to building 2. It's a 3-tier design. However, going to building 3, that's now a 2-tier design, because we have 1 tier being the core, and we have a 2nd tier being the collapsed distribution and access layer. All right, so that makes sense because, again, it's just a small house. There's no reason to deploy 4 switches into this house. I mean, can you imagine being the network admin going to the CFO and saying, all right, we need 15 users. So what I've done is I've created this design that's got 4 different switches. The 2 switches are going to have 12 ports each. There's the distribution layer, but then the access layer switches are going to have 24 ports each. That way I've got plenty of redundancy in case one of those goes down. I mean, the CFO is going to be scratching their head and saying, I think we can get away with just a single switch here. Can we just do a single switch? And this is where we as network engineers, we get bogged down sometimes in what's right. We have spent so much time studying this stuff and saying, you know what, I've studied it. I have maybe you've got my CCNA, or I've got my CCNP, or dare I say even some of us may have a CCIE. Like I've studied this. I've invested all of this time into this, and I've read the books and I've read the white papers, and I know for a fact that the right design is to put 4 switches into that place. Now, if it's a house, you're probably in the back of your head thinking, okay, maybe I don't actually need 4 switches here. But what if it was a larger building that still only had about 30 users? I mean, would you still want to deploy 4 switches or a single switch? Would you argue for 2? Would you argue for 4? We always have to find the compromise. Again, working for a Cisco partner was interesting because my job was to come in really and focus a little bit more on finding a compromise, because I'm always in the position of like, this is the best, right? I mean, like I've got this great new Cisco technology, brand new switches, whatever it is, and it's the best thing that Cisco has ever created. And oh yeah, you've got a budget that's about 20% of what that would cost. And so there's always this balance of, I'm not a salesperson. I'm not paid based on commission. And so, like, I don't care. Like, it doesn't affect my paycheck whether they buy one solution or the other. But at the same time, it's like, I know that there's this awesome solution that would be a great fit here, but your budget isn't quite there. And so my job is to bridge that a little bit, to say, okay, what can we do that's within your budget? That's maybe the good solution. If you could increase your budget a little bit, this would be a better solution. But very rarely are you going to find that we can triple your budget and say, you know what, let's just do it exactly like the book says and, just completely blow past the budget. It just doesn't fly. And if you're in a consulting role, you understand that. And if you're in an IT role for an organization, you might even understand that better than me because you've gone to your boss to try to argue for more money to do things the right way. And at that point, there's a crossroads that we hit as IT individuals. We are kind of stuck in this world or in this place where we have to decide, are we going to go along with the business? Are we going to respect the business? Or are we going to more or less get in a huff and complain to everybody that they don't respect technology here, they don't respect me maybe? I mean, it's going off a little bit of a tangent, so I apologize. But one thing that is hard for me as an instructor and as just a content creator and such is to see individuals who take it too personally and possibly miss some good opportunities to sit in a role and learn from that role and to get all that they can out of that role, even if it means eventually leaving and going on to bigger and better things, because the business doesn't respect IT. We in IT need to make sure that we are respecting the business, because the business is what keeps us in business. The business is what puts a paycheck in my pocket. The network doesn't put a paycheck in my pocket. The network does nothing for providing the business with profit. All right, the revenue streams, the profit, that all comes from whatever the business is in business for. The network doesn't write checks to the organization. That's what the customers do. And so if we in IT get in the way of either potentially bringing in revenue or possibly increasing costs too much, then we become enemies of the business. And that is not a good mindset, especially in an age when the organizations that are hiring IT folks like us are looking for higher level opinions, higher level thinking. Imagine two network engineers, one who's really, really good technically and one who's maybe not as good technically, but can speak the business language of how to leverage technology to improve return on investment, to take a CapEx expenditure, a capital expenditure, a CapEx spend, and convert that to an OpEx spend, and how that can relieve profit margin, revenue streams over time. All right, imagine those two scenarios. Who do you think the CFO wants in his or her corner? Probably the one who's a little bit less technical, but understands the business a lot better. All right, and so that just think of it from that perspective. Like the more that we can be useful to the business, just flat out, the more useful we are, and the more invaluable we are, and the more our opinions will be respected. As soon as the business thinks that we're just in the business of building the best darn network that we can, and who cares how much it costs, that's when the respect for us and for IT in general starts to go downhill. All right, so that's my soapbox. I apologize for that, but at the same time, I don't apologize for it because, again, I've seen it, and it's painful, and we can do better in the networking world. All right, so let's figure out what works best for each individual situation. Now, here's another way that we can collapse, okay? Collapsing can go multiple directions. I mean, we've got a sandwich, so to speak. We've got three tiers. We've got the core at number 1, we've got the distribution at number 2, and we've got the access layer at number 3. And we can collapse the distribution into the access, which we've just seen, but we could collapse the core into the distribution. For example, let's look at building number 1 here. What if I said, let's collapse these two together? What would be the benefit of that? Think about that for a moment. why would we want to collapse the core and distribution layers together? I mean, what does that accomplish? Well, remember what the role of the core is. We only spent like 5 minutes on it 2 weeks ago because it was pretty straightforward. It was, my job is layer 3 switching. That's all I care about. My goal is to take a packet in from one network block and send it out the other appropriate network block, or towards the appropriate network block. So if I have a distribution switch whose job it is to handle SVIs and ACLs and such, and first hop redundancy protocols, do you think that that distribution switch could also do some high-end layer 3 switching? In most cases, yes. And so I've got my headquarters. Building 1 is my headquarters, let's say. And yeah, I've got all my access closets everywhere. But here in maybe it's in my data center, maybe it's in my MDF, where these feeds come in, right? I've got the internet coming in. I've got my data center coming in. I maybe even have these other fiber connections coming in, whatever building that is. Usually it's an MDF closet or something along those lines. I've got 2 pretty darn good switches serving as my core. Now, am I then going to deploy a pair of distribution switches right next to it to connect all the access closets? Now, if I have 100 access closets and these core switches are small, then okay, there's value in that, because now the distribution switches can have 48 ports each and connect out to all of the, I don't remember how many closets I said, hopefully that's enough, but all of the access closets, right? Now that makes sense. But if I've got 12 access closets or 5 access closets, and I've got these core switches with all these interfaces on it, what's the value in deploying distribution switches other than, as we've said already a few times here, other than just to stick to what the book says and to deploy a 3-tier architecture, because that's what we want to deploy. In a lot of cases, collapsing a core layer into the distribution layer where the core is housed makes a lot of sense. The biggest time that it doesn't make a lot of sense is when you have a ton of access layer closets. Then yes, it makes sense physically to have separate distribution switches and then have core switches that their focus is on switching all of these different the traffic between all these network blocks. Okay, so do we see though that we can collapse 2 different ways? We can collapse distribution and access together. That's a 2-tier architecture. I've got a core block and I've got a distribution access. But I could collapse the other way as well. I could have an access layer switch down here or access block, and then I could also have core and distribution blocks collapsed together. This is now a core distribution, what we'd traditionally call a collapsed core design. What's interesting in all of this is, even though we have a 2-tier architecture now on the right, and we have a 2-tier architecture here in the middle, look at this building 2. Look at this right here. This building 2 still has a dedicated access layer. It still has a dedicated distribution layer. And it still has a core layer. Its core layer happens to be collapsed in with the campus environment at building 1, but it's still a dedicated core relative to building 2. So we still have a 3-tier architecture for building 2. This is where it gets gray. I mean, I hope we're starting to see this a little bit. It's not as simple as saying, hey, you're either a collapsed core or you're a 3-tier architecture, especially when we have many buildings that are at play. And as if that's not enough, check this out. Let's change color and do one more here. Now we get building 4. My brain's going a couple different directions here. Let me do it like this. Let's say that headquarters is actually pretty small. Maybe we're at a factory. We've got a campus and it's a bunch of factories, and headquarters is this little admin building with 15 users. Well, now we could have truly just, building 3 is a collapsed access layer, collapsed distribution layer. It's a 2-tier architecture like we have drawn out. And building number 2 here in the middle, that's a factory that we've got the 3-tier thing going. But now at headquarters, we're just going to deploy all of this into one switching layer. We're going to deploy 2 switches that connect out to all of the different blocks in all of the different buildings. And it's going to perform the SVIs and the ACLs for my headquarters. And it's going to connect all my users in. All of my users are connecting in via these same 2 switches. Now we've collapsed the core and the distribution and the access layer all together. So that's a completely collapsed design. That's not even a 3-tier architecture anymore. I'm sorry, a 2-tier architecture. It's a 1-tier architecture. This is where real-world design meets book design. And here's the crazy thing about this. Did we violate the design by doing that? If we collapsed all of that into a single pair of switches, did we violate the 3-tiered architecture? Technically, we did not. Because look at all the roles. We've got layer 3 switching in here on the pair of switches. We've got SVIs and ACLs and first hop redundancy protocols all running on those switches. We've got VLAN and QoS marking happening for the users that are attached to those switches. So we have all of the roles accounted for on that single pair of switches. So in the end, design, I always have said that network design is closer to art than it is to engineering. And the reason for that is there's some subjectivity out there, and subjectivity can be a dirty word to an engineer. I mean, we're math-minded, right? We like 2 + 2 = 4, and therefore there's always a right answer to whatever the situation is. But if it's that small, does it make sense to deploy 4 switches and still try to get a 2-tier architecture out of it? Could we go with 2 switches and just collapse them all together? And I mean, there's some gray area in there, and the engineer who designs it is probably the one who's going to end up deciding what is right in that scenario. And nobody's going to look at it necessarily and say, oh, you did the wrong thing. I mean, if I were to go into a small building like that and there's 15 users and you've got 6 switches for the 3 different layers, I mean, yeah, I'd say that we can probably definitively say that that was over-designed. But whether 4 switches is over-designed or not, it might be in the eye of the beholder. And that's, again, where it's like a little closer to art than it is to engineering. So there are going to be some scenarios that are very crystal clear how to do it. There are going to be some scenarios that require some opinions. And the best recommendation I have for you, if you find yourself in that situation, is bounce it off a couple of people. You know, if you're a consultant, bounce it off the customer, bounce it off the salesperson. You know, I know, right? Like, what? The salesperson? Yes, the salesperson has a sense of whether the customer will take offense to you coming in there with 4 switches and whether they have the budget for that. I mean, that's the kind of thing that weighs into a design like this. And so ask some opinions and do your best to find the right solution. If you're an IT person and you got Cisco coming in and trying to sell you on 4 switches, ask some other technical minded people in the industry. Reach out to somebody in this study group or on Twitter or what have you and just say, hey, this is what's being proposed. Does this feel right? Does this make sense? And you just gather opinions and you do what you feel like is best. And that's all we can do. That is all we can do. All right. So that is already the first 30 minutes is just discussing 2-tier and 3-tier designs. And we thought that was straightforward, right? Like, 2-tier design, that's just going to be collapsed core. Yeah, no, it's not quite as simple as that, unfortunately. Not in the real world. Now, from an ENCOR perspective, if Cisco's going to ask questions about 2-tier and 3-tier network design, just understand that we can collapse networking blocks together, and we can collapse a lot. We could collapse the data center into the core. We could collapse the data center into the distribution layer on the campus. I mean, collapsing simply means that we're deploying multiple roles onto a single set of switches. That's all collapsing means. So collapsed core, yes, that's typically what we had in green here, where we're collapsing the core into the distribution layer. A collapsed distribution layer can be referring to what we have here, where we have a distribution access combined together. Usually they'll be a little more straightforward on an exam about what they're asking about than what the real world often gives us. And that's not a bad thing. Okay, let me clear my screen here. And we will delve into, I'm going to mark off where I can't draw, or I'm not allowed to draw. Delving into the access layer. All right, so we have a lot of different options when it comes to the access layer. We drew it out really nice and pretty. We were really more focused on the collapsing of blocks in the last drawing, but now we need to get into not only the physical layout of access layer switches, but also what type of access layer connectivity we're going to create. So First and foremost, when it comes to access layer design, we do typically have two main options. Access layer is going to be either a layer 2 design or a layer 3 design. And not to jump ahead or give anything away, but in most networks, access layer is going to be a layer 2 design. And we'll see why here in a moment. Every now and again, you will run across a layer 3 access layer, but that's better in theory than it is in practice. Again, well, let's talk about this. So what are we talking about here, really? Well, we've mentioned having a core, well, I should say a distribution layer. Maybe it's a collapsed distribution or collapsed core design. But either way, we've got a pair of switches, ideally distribution switches. And then I've got a bunch of access layer switches. Now, these access layer switches, one thing that can get us into trouble as network engineers when we're trying to merge theory and practice is the actual physical layout of where all these switches are. So I might have an access closet here, and then I can connect these up dedicated to those distribution switches. But then maybe I've got 5 access switches in the next closet. And so now all of a sudden, does it make sense for me to connect all of these access switches to my distribution switches? I mean, yeah, we'd love to say, all right, 2 connections to that switch, 2 connections to that switch. It's usually not going to happen. So in a lot of cases, what we end up doing, I should say it like this. What we used to have to do when we didn't have better options was we would typically loop this through. Okay. Spanning tree would block a link in the middle, assuming this is a layer 3 or layer 2 design. And we just made do with what we could. Now there is another design here that's kind of popular, or that was popular, which is to dual home to the head end switch, and then we'd block one of those links. And that made it so at least we're consistent with how many hops that we had to get out to the rest of the network. But the problem with this is if that switch goes down, then we lose total access to that network closet. So there's really, it's kind of a rock and a hard place conversation. Well, we typically will go with this from a layer 2 perspective. We're going to talk later about chassis and stackable switches and VSS and such and how it makes our lives easier. For now, let's just leave it like this. So the idea here is this. I've got users connecting in these access switches, and I've got users, draw it here, connecting into these switches. In a lot of cases, my users need to be on the same subnet. And there's a lot of reasons for that. Sometimes it's, well, my users need access to a printer that can't handle layer 3 traffic or something silly like that. In a lot of factories and warehouses, RFID scanners have to be on the same subnet as their server. Sometimes it's just flat out organizational. Like I want all of my users on VLAN 10. I just want them all there so I can apply security policy to VLAN 10 and know that they're on VLAN 10. Wireless roaming was a big problem, or was a big reason for this, because if I roamed from this access point to this access point, because I'm walking down the hall, and so my wireless user is connected here, and then I roam over here, and now all of a sudden I'm connecting to this access point. Well, I would like to keep my IP address in that scenario. I mean, I might be in the middle of network communications. Maybe I'm watching a stream. Maybe I'm on a video call. Whatever the situation is, if my IP address changes, it's going to interrupt what I'm doing. And so we didn't like layer 3 roaming. We want layer 2 roaming. And so this enables this. So a layer 2 domain says that I'm going to stretch my, I'm going to put trunk connections to all of my switches in my access closets. I'm going to extend all the VLANs I want. So maybe this is VLANs 10 through 20 out here, 10 through 20 out here. And maybe I'll try to keep it a little clean. Maybe I need VLAN 25 on the second access closet for some reason. So I'll add VLAN 25 to that trunk link. And those trunk links, really all of these are trunk links at that point. And that's well and good. It keeps it cleaner because I don't need to extend VLAN 25 to the closet on the left, and that's well and good. But the biggest problem with this design is my increased risk of network outages. We all know it. The industry knows it. Ethernet's kind of a terrible protocol. I've said that before. I'll say it again. It's kind of a terrible protocol. It was a cheap protocol. It's why it won the war back in the day. And we've built the entirety of our modern internet. Oh, there's my camera again. We've built this modern networking world on kind of a crummy protocol in Ethernet. And so what we find ourselves doing here is just dealing with the pain points of Ethernet, one of which, and the biggest of which, probably, is this concept of network loops. So I need the redundancy of loops, because if I just do one connection and it goes down, then everybody disconnects, and that's not acceptable. So I have to have redundant connections, which means I have to create network loops, which means I have to have, as we all know, spanning tree protocol, or STP. Spanning tree is going to go in there, it's going to block one of these links, it's going to make it so there isn't actually a network loop. Logically, physically there is. And we're trusting and hoping spanning tree works. And spanning tree, for the most part, likes to work. I can tell you from experience that spanning tree also likes to occasionally completely fall on its face. I could tell several stories of this. There was one where I was in a large medical clinic. This was when I worked for this medical clinic. And we had a access closet, or access switch that was hanging off of a pair of distribution switches. And my job was to connect the second link up because we didn't have the fiber run or something like that. And we just didn't have that capability of firing that up. This is one tiny access switch that was on a building just off of the main campus. I just needed to connect it back up to the distribution using the new fiber that had been pulled. And so I went there about 1 o'clock in the afternoon or so, right after lunch, and connected that up. And spanning tree should have worked. Spanning tree should have blocked that port. Spanning tree did not. Spanning tree took that network to its knees in about 40 seconds. And, fortunately I realized it pretty quickly and took it down, but, it was a, 3 or 4 minute outage, and all, it wasn't a good scenario. I had to really state my case of being like, okay, look, spanning tree failed. It should have worked. And literally the next time, because I killed that link to save the network. And when I went out there, in the middle of the night next time, of course, to do this, I did the exact same thing. I just connected that up and boom, spanning tree worked and life was good. So unfortunately, I got to experience spanning tree failing at its finest. I also saw spanning tree fail in a large data center where I got a call from a customer and their spanning tree process just died on one of their distribution switches. Inexplicably stopped sending BPDUs, stopped processing spanning tree packets, allowed the network to form a loop, and took down a data center. And it was a very painful outage for this company, unfortunately. Really, truly, it was very bad because their data center lost all of its virtual machines, and they all got corrupted because even though the network outage didn't last very long, all the virtual machines got corrupted, and they ended up being hard down for 24 hours just because of this silly switch. Stop talking spanning tree. So, spanning tree fails, and it stinks when it does. And so, the biggest problem with what we're doing here from a layer 2 perspective is that we're increasing our failure domain. We're increasing our broadcast domain. And so, number one, well, I guess those are two separate things. Number one, we're increasing our failure domain. If anything were to go wrong with spanning tree in this, everything goes down. Okay, it's not just one access closet, it's all the access closets because those distribution switches are going to get overloaded and it all goes down. Plus, broadcasts get propagated everywhere thanks to our trunks. The broadcast domain itself is a separate issue because even if spanning tree is doing its job, any user that sends a broadcast packet to the network is going to be delivered to every single user on the entire network. And that doesn't sound too bad until we realize how much broadcast traffic there is on a network. There's a tremendous amount of broadcast happening every single day or every single minute, potentially, by a lot of our end devices. So whether it's DHCP related or it's some other application that was poorly coded and it's broadcasting out instead of using unicast or multicast, either way, we have to deal with the fact that there is a lot of broadcast network. And so the larger we make our broadcast domain, the more overloaded these distribution switches are going to get and the beefier they have to be from a processing perspective in order to handle the load. So this is where the concept of layer 3 comes in. Because if I can just get rid of the broadcast domain, if I can just get rid of spanning tree, all of those problems go away. And that sounds great. What if I were to turn these into layer 3 links? What if I made it so it's no longer trunking? Now every one of these dots represents a layer 3 interface, and we are no longer trunking. This is now layer 3. So my closet on the left has layer 3 connectivity to the distribution layer. That means that I'm running a routing protocol. Let's say I'm running EIGRP here. It also means that my roles and responsibilities of the distribution layer have actually now been offloaded to the local access switches. So everything we just talked about, how the role of the distribution layer, involves the SVIs and the first hop redundancy protocols and the the access control lists, for example. All of that now needs to go on these layer 3 access switches. So we deploy the SVIs here. We would deploy the access control list. We deploy first hop redundancy protocol here. So one of the problems, so to speak, with this type of configuration is that it can increase the complexity from the perspective of now I've got to go around and configure first hop redundancy protocols on every single access switch in my infrastructure. And that's not always ideal. But it's also not a whole lot worse than configuring trunks and managing VLANs. And so to me, that's a wash. There's layer 2 complexity and there's layer 3 complexity. And regardless of which solution you choose, there's going to be complexity. It's just the fact of life. So what is the disadvantage to this? Well, we already talked about it. If I'm going to roam from this access point to this access point, now it's a layer 3 roam. VLAN 10 is not shared between the two different closets. In fact, there are no VLANs that are shared between the closets because it's layer 3 segmentation between them. We cannot share a subnet between layer 3 separated domains. So that means that if I have any application that requires layer 2 connectivity, not going to work. If I'm going to do roaming, that could potentially be a problem. Now, I will say this, even though we use this as an example a lot, wireless LAN controllers kind of solve this problem for us. Because wireless LAN controllers make it so that these access points can be in separate layer 3 domains, and they tunnel user traffic back to a wireless LAN controller. And that wireless LAN controller makes it so that even if I roam between access points in different layer 3 domains, I'm still part of the same wireless subnet. Okay, so wireless LAN controllers can make some of that go away. And honestly, that was one of the biggest pain points of layer 3 access layer. So this is why some places do choose to go with a layer 3 design. Well, wireless roaming is actually kind of handled for us. We can get rid of spanning tree. We can get rid of trunking and get rid of our broadcast domain issue. These switches might be able to be a little bit smaller, just small layer 3 switches instead of big beefy layer 2 switches. Layer 3 has a lot of advantages, but it can be torpedoed by one application showing up that requires layer 2 connectivity. And this and what's unfortunate is you can design this beautifully. You can do all of the research and do all of the investigation and find out we're not doing any of that. We don't need any of that. Life is good. Let's do layer 3 everywhere. You deploy layer 3 everywhere. And then your HR department goes out and buys something that requires their PCs that are located in 2 separate parts of the building to be on the same VLAN. And so they're coming to you and saying, we just invested $100,000 in this application and it requires layer 2 connectivity. Again, to our earlier conversation, we as the network engineers have a tendency to say, I'm putting my foot down. We're not touching this layer 3 design. We did all of the research. You went out, you bought that application, you wasted your money. Good day. And how many of you think that that's actually going to work out well for you? HR department spent their money. They need that application in order to do their jobs better. And we are now in the way of that. And so having a layer 3 design, honestly, as much as anything, it brings a lot of risk with it. Like, that's my biggest care about is I'm risking having to revert to layer 2 by something that's outside of my control. And so we could spend all the money again and do all the research and do everything, all the consulting and all the engineering hours needed and convert our entire network to layer 3 and then find out we have to convert it back. So layer 3 really corners us, pigeonholes us, however you want to say it, it makes it so that we aren't flexible. And that is a big problem with networking. So, where has networking really gone? Well, where networking has really gone, let me see, can I get rid of some of these layers? All right, look at that. Where we have gone is to embrace, oh, I gotta actually create a new layer. There we go. Is to embrace layer 2, begrudgingly. We're not doing it with pride. Like, yes, layer 2 is awesome. No, that's not what's happening here. We're embracing the need for layer 2, the flexibility that layer 2 gives us. And what we're going to do is we can't get rid of spanning tree, okay? The dream is to just cross that out and be done with spanning tree. Instead, what we're going to do is we're going to drastically reduce spanning tree's domain and greatly reduce our reliance on spanning tree. Here's some of the ways we do this. First of all, some of this technology, by the way, has been around for a long time. So, like, I'm not saying this is new. I'm just saying that this is where the industry went. Okay, first of all, we have this concept of chassis switches and the concept of stackable switches. Sometimes we'll go with one over the other, and we're not really going to delve deep into why we choose one over the other, but, you know, chassis and stackable is always a fun conversation. Either way, we take multiple switches. Let's say I've got 5 switches, like I have in the diagram down here. 5 switches, and I can put it into a single chassis with 5 different networking blades and maybe a supervisor in there. I think I got 6. Nice. So I could put into one chassis, or I could stack them together. And so now I've got 5 switches that usually have some kind of back-end cable. And then that kind of got a little messy, but you get it, right? Here's the chassis, here's the stacks. Either way, it's a single logical switch. Okay? And so what we end up with, you know what, I'm just going to get rid of that other layer. There we go. Put layer 2 in there. There we go. So what we end up with is we've got a couple of, there we go. A couple of distribution switches. No need to make it so big. And then we've got a chassis. Let's just go with chassis switch. So I've got a network closet with a chassis switch in it. And I bring my connections in, and now my spanning tree domain is greatly reduced. Remember that loop, that nasty loop through the access layer? We don't have to worry about that anymore. Okay, we do still have spanning tree in this domain, but there's a whole lot less that can go wrong with spanning tree when only one link is blocked. Well, usually there's one link. When we only have 3 links, and it's a triangle. Yeah, we want to get rid of those large looped domains and get as close, or get as many triangles as we can. And so then I've got another chassis. Maybe it's even in the same network closet, and same concept where I'm going to extend 2 connections down. One of the other pain points I didn't mention about spanning tree, by the way, is that, well, wait a second here. I've got these fiber links pulled, and I'm not using them at all. Okay, what we got here? We got about 10 minutes. So what we can do is that make, well, okay, let me say that one more time because I got distracted. So if spanning tree were to block those 2 links right now, we are not sending any traffic across these 2 connections. They might as well not be there unless I need them for redundancy, unless the primary connection goes down. However, one thing we can do is get a little bit clever. We can leverage Cisco's per VLAN spanning tree, PVST plus, and ideally in this day and age we do rapid. So rapid is a faster version of it. We'll go with rapid PVST plus. And PVST allows me to have multiple spanning tree topologies. So what I'm going to do is I'm going to deploy 2 topologies. I'm going to deploy a topology that looks like this, where I'm blocking that link. And then another topology, let's make this topology orange, I guess. And that topology is going to look like this. Now these are not new physical connections. This is simply spanning tree topology. And what I can do is I can make it so that VLAN, let's say VLAN 20 here, this is the root bridge for VLAN 20. Wow. The root for VLAN 20, and therefore my blocked link is over here for VLAN 20. Meanwhile, I'll switch back to that pink, and let's call this the VLAN 10 root. So now, because this is a separate root bridge, I'm going to block something different, and my blocked port is here for VLAN 10. What that means is that VLAN 10 traffic gets to go down this link, and VLAN 20 gets to go down the other link. Now, it's not perfect, because VLAN 10 might have 5 times the traffic of VLAN 20. Who knows? But it is better from the perspective of I can use both links. I can use physically both links. Logically, VLAN 10 can only use one of those links. Logically, VLAN 20 can only use one of those links. But I am using both of them by combining that. Now, if I only have 2 VLANs, one of those VLANs is probably has way more traffic than the other. But if I average this out across 10 VLANs or 20 VLANs or more, well, law of averages says that I'm probably going to end up with about 50% of my load out each link, which is ideal. So there we go. We've gotten clever using Cisco's PVST+. We can block different links and make the most use out of our connection. So that's something that we have done in order to make layer 2 more palatable for us. We've reduced the spanning tree domain, and we have increased our efficiency. Okay, so spanning tree is down, efficiency is up. However, we didn't stop there because these 2 distribution switches, we could combine those into a single chassis. Like, what if I were to deploy a single chassis switch as the distribution layer? Well, let's draw that out. What if my distribution layer is a single chassis? Maybe it's a large chassis. Maybe it's, I'm trying to draw it large. There we go. Lots and lots of blades in it. And that's going to connect down to a single chassis that's in my access closet. Well, when I have a single logical switch connecting to a single logical switch, I can leverage Cisco's multi-chassis ether channeling, or MEC, which is something we don't talk about a lot because we just sort of assume that it, there's no magic to it. It's almost one of those things where it's like, I don't know, it's networking magic that we take for granted, the fact that it works. And the reason we take it for granted is because we have one logical switch connecting to one logical switch, and we assume that we can ether channel that. But there's a lot of magic that has to happen behind the scenes in order to make that actually transpire, because chances are these connections are connecting to different switch modules within the chassis. At least they should be for redundancy. So we could do that, but that doesn't make me feel great, because now my entire distribution switch, or my entire distribution layer, is a single switch. And if that switch has any freak out problem, well, I've lost my redundancy in the distribution layer. So instead, what we have is we have a technology that is called, dramatic pause. It is called the Virtual Switching System, or VSS. Okay, right. Yeah, all right, good. Forgot to put my big X where I can't draw. All right, VSS. Maybe you've heard of this. VSS allows me to take a second chassis switch, which you're saying, all right, Jeff, this is already looking like the diagram in the top left. However, I can actually combine these two into a single switch as well. So now I've got 2 chassis switches that are combining into one logical switch. And that is what we call a virtual switching system, or VSS. Now, one of these ports can go to the purple switch, one of them can stay connected to the green switch, and I can still do a multi-chassis ether channel, because Cisco has created some magic in order to make that happen. Again, logically what this looks like is one switch connecting to one switch via one connection. This is what it looks like. And so, yeah, is spanning tree running? Yeah, spanning tree is running. We're sending BPDUs down from the root switch. The BPDUs are flowing, but we're not blocking any links, and we don't have a massive broadcast domain to worry about here. There's a lot less that can go wrong in this environment from a spanning tree perspective. Now, VSS is, can be a complicated protocol to deploy, and managing software, doing software upgrades and such. We do introduce more complexity from there, but for steady state network operation, things are a lot smoother. All right. Now, here's a question. Can we do VSS with stackable switches? And the answer, believe it or not, is yes. We are to a point where Cisco has some Catalyst 9Ks that can do VSS between the stackable switches. And so we've got that as an option in some cases. I believe that's true. I might have to double check that. But either way, the stackable switches we got a lot of different options there. As long as we can get down to this topology right here, that is the ultimate goal of collapsing this layer 2 design. then the benefits of layer 3 are less evident, because as we do this to multiple blocks, again, we've got another access closet down here, and we do the same thing. Well, now it just looks like this, where I've got an entire access closet writing on this chassis, and I've got an entire access closet running on, maybe that's a stack of switches, and then I've got the VSS running in the distribution layer. So we start to see how these technologies can really improve our ability to deploy, to manage layer 2. Let's put it that way. All right, I know I'm out of time, but I'm going to ask for like 3 more minutes, because I was hoping to have more time for this, so I'm not going to spend a ton of time on it. I want to respect everyone's time. But this is important, okay? Cisco has this concept of software-defined access, or SDA. Maybe you've heard of this. If you've heard of DNA, for example, Digital Network Architecture, or DNA Center is an SDN controller that manages software-defined access, which is itself a software-defined networking solution. So many buzzwords, so many acronyms, but hang with me on this. Software-defined access does this. It says, I'm going to put my, think of them as distribution switches in the middle here, and I'm going to connect out via layer 3 to all of my access layer switches. Ideally, these access layer switches are chassis or stackable switches or something along those lines, because I don't want access switches hanging off of access switches, okay? So if I've got 2 access switches in a closet, ideally I've got connections out to both of them. Okay, and these can be redundantly connected. That's not a problem. It's all layer 3. So of course it can be redundantly connected. There's no network loops in this, which is awesome. So what we've just done here is we've created this concept of an underlay. An underlay, as I like to describe, is what we have. Okay? Underlay is what we have. We truly have 1, 2, 3, 4, 5, 6, 7, 8, 9 switches in this network. Okay? That's great. I'm going to make this darker. Hopefully everybody can still see that. And the idea of software-defined access says this. I'm going to take these edge switches, and let me just make them a little bit easier to see here. And take these edge switches, and I'm going to form tunnels among all of them. So like a full mesh of tunnels. So this switch is going to have connection to all of these switches. This switch is going to have connection to all of the switches. And I made too many switches in this diagram, because now, holy smokes, that just continues to be more and more, but we're almost there. All right, there we go. I think we got them all. So we've got a full mesh of tunneled connections. Now, imagine me coming to you as a design engineer and saying, let's do this. Let's just tunnel everything together in a full mesh of tunnels. Would you want to manage however many tunnels that is? I should hope not. I would hope that you would have shown me the door 10 years ago if I had showed up saying we should do this. However, DNA Center, which is hard to see, DNA Center, as our SDN controller, is going to be able to deploy these tunnels for us. And these tunnels are VXLAN tunnels. VXLAN tunnels are capable of transferring layer 2 information, which means that even though I have a layer 3 underlay, I have layer 2 connectivity. So if I have hosts on these 2 switches, I could have them be on the same subnet on VLAN 10, same subnet on VLAN 10, and they can send broadcast traffic to each other. This is a layer 3 architecture. There is no spanning tree in this design. And yet I've managed to place these 2 whatever they are, PCs, clients, whatever, they're on the same subnet. They're on the same VLAN. This is called an overlay. We can't see that. There we go. VXLAN says layer 2, by the way. Layer 2. Kind of like that. Anyways. Overlay. This is a network overlay, otherwise known as a fabric sometimes. So we create this fabric, we create this overlay. It's a bunch of VXLAN tunnels. And we use a control plane protocol called Lisp in order to tie all of this together. Lisp is basically going to say, Lisp, locator ID separation protocol. You've probably heard Cisco say it a couple of times. Lisp is going to tell this switch right here where host A lives. Host A lives on switch 5. A lives on switch 5. And now that switch knows that when traffic comes in, destined for host A, I send it in a layer 3 tunnel. It's a layer 2 tunnel, it's VXLAN, but it's across a layer 3 connection. The underlay itself, I said that wrong. I'm going to send it across the underlay. I'm going to encapsulate it and send it across the layer 3 domain from me. Maybe I'm switch 4. I'm going to send it from switch 4 to switch 5. Okay, switch 5 de-encapsulates it because it's VXLAN. It carried the layer 2 information, and I can drop it off if it's a broadcast packet. I'm just going to drop it off with that particular host, or all of the hosts on that VLAN if it's a broadcast packet. So truly, okay, that wasn't quite 3 minutes. It's a little long. I apologize. But, I mean, that's SDA in like a 5-minute nutshell. All right. Now, we've got a lot. There's so much more to cover with SDA. We are going to cover some of that here in the ENCOR study group. So we're just getting rolling with the ENCOR blueprint. Cisco expects us to know about software-defined access. They expect us to know about VXLAN and Lisp. We're going to have conversations about VXLAN and Lisp. And so I just wanted to kind of lay the foundation at this point to say that there is a best of both worlds approach. SDA gives us layer 3 out to all of the access switches and yet allows us to bridge layer 2 among them. So truly, spanning tree is gone. Like, remember my little arrow? I was like, we can't cross out spanning tree. We can only reduce it. Gone. Spanning tree is gone in an SDA environment. And yet we have all of the benefits of having a large layer 2 domain. So that's a pretty good deal. So in 2 weeks, on July 29th, we're going to be covering high availability techniques. So that largely includes first hop redundancy protocols. We'll cover a couple of other concepts as well in there. And again, we're going to continue to march through this ENCOR blueprint. So hope this has all been useful for everyone. Please don't hesitate to, again, bring your questions now, bring your questions next time as you continue to work through the ENCOR blueprint yourself on your own study time. So with that, I'm going to leave this video running for another 5 to 10 minutes. I will be in the chat answering any questions if you have anything. Otherwise, I hope everyone makes it a great day. Bye-bye.